Hey, thanks for stopping by. Today we're going to be wiring this electrical panel in detail. Pretty much cover everything start to finish as much as possible. So please get a cup of coffee and a notepad. I think there'll be a few things that you and I can learn together as we go through this process. There are links down in the description to materials that you'll need for this project, as well as other videos where I cover some other electrical topics more specifically. And then also, this video was a ton of work to make, so if this ends up helping you out, would you mind hitting that thumbs up button and sharing the video? Subscribe to the channel if you want to see more videos like this one, and hit that bell icon to be notified about future videos. Alright, let's jump into this project. My name is Ben, by the way. Before you do any electrical work, you're going to want to get the proper permits to do so. So make sure you do that before you get started on your electrical project. And then we're going to want to have all of our circuits pulled to our panel location. So I've got all my circuits pulled already here and have them marked for where they are coming from and going to. And then we're going to want to fully disconnect power from the panel. We really want to get the power 100% disconnected so that you don't have to work around those live lugs during the duration of your project. So if you have a cutoff panel like I do, you can simply go out and turn off that cutoff panel and put a lock on it to prevent anyone from accidentally turning on the power. But more likely you're going to have an electrical meter that's going to have to be pulled out of its socket in order to disconnect power. Because typically your meter would be mounted on the outside of the house, and then those wires would feed directly into your main panel. So you'll need to contact your electrical cooperative or whatever electrical company that you have and ask them the procedure for getting your meter pulled out of the socket in order to get your power fully disconnected. So here you can see we've got all of our different wires coming from our cutoff panel, or it would be coming from your meter normally. So if this was a standard panel and you did not have a cutoff panel, you'd have your two main legs of 120 volts each and a neutral in the middle. You would have a ground wire, which is right here, that would be coming from your grounding rods. Since this is technically a sub-panel, we have one more wire, which is this one right here. This is a ground wire that goes all the way back to my cutoff panel and ties into the ground there. Therefore, you have to have your bonding screw removed. There's a bonding screw and or a little copper piece that goes from your neutrals to the cabinet or casing of your panel. And if it is a sub-panel, you have to get rid of that. You have to take it out. Take that green screw out. In the case of this one, there's a green screw that bonds this to the casing. That cannot be there. Take that out and add a ground bar. You'll have to actually add a grounding bar to your panel if it is technically a sub-panel. Now I'd suggest adding a grounding bar anyway, depending on the layout of your panel. Some are really intuitively designed. Some have it's more difficult. So I put this grounding bar here initially because that's how far my ground wire reached. I added a second ground bar right here so that I can land all my grounds down here and keep my gutter space over here pretty free, because it's kind of tricky to get that many ground wires in right there. So now I have the option of bringing all my wires down here, or this side, I'm not sure exactly yet, and pull all those grounds up into this ground bar down here. And the ground bars, you should make sure you always have one that is the same manufacturer as the manufacturer of your panel. So right here is our number 6 solid copper ground wire that goes out to our 2 grounding bars located outside. And those grounding bars are pounded in the ground 10 feet apart from each other. And that grounding wire then connects onto the grounding bar in this particular panel, because it is technically a sub-panel. But if this was a normal service entrance panel where you didn't have a cutoff panel, that copper wire would just hook straight into the neutral bus. This is a QO2D 40 space panel, and if you can, there's a couple different types of panels now. Some of them are what they call plug-on neutral, or that's what Square D calls it at least. And a plug-on neutral panel basically has a neutral that runs down right here and right here, so that you don't have to use pigtail arc fault and ground fault breakers. So this is a dual function breaker. I'm going to have to roll all these pigtails up in the gutter here and connect them to the neutral bar and then bring the neutrals directly to this. So if you can get one of the newer style panels, you don't have to deal with all these pigtails, and this snaps right on there, and you don't have to worry about all of the pigtails. But if you have an existing panel and it's adequate, go for it. Always opt for a panel with as many spaces as you can get for a 200 amp panel. I saw a guy recently, I think he said it had 52 spaces, and it was a plug-on neutral QO square D panel. That would be the optimal way to go. When I got this panel, those options weren't yet available. So you're going to want to stock up on all the stuff that you're going to need for doing your project. It's worth it to just go ahead of time and make sure you have everything that you need. In my case, it's a lot of arc fault breakers, because arc fault breakers are almost required everywhere in the house. So arc fault or dual function. This is a dual function. It's both ground fault and arc fault. They all are going to have these pigtails unless you use the plug-on neutral that I was talking about, where this terminal right here acts as your neutral. In my case, I need to use the ones with the pigtails because I do not have that option. Now, there's never going to be two panels that are wired exactly the same. Especially just varying from company to company, electrician to electrician, are going to have different methods for wiring panels. Overall, there's a lot of different ways that it can be done that is going to meet code just fine. But it's a huge variance from rat's nests, or what look like rat's nests inside of here, to meticulously placed wiring in the entire panel. I'd recommend the latter, so that you have something that you really can wrap your mind around. When you look in it, it should be pretty self-explanatory to see what exactly is happening. And especially if you're going to wire it yourself, make sure you take the time to do a really neat job so that your inspector will be pleased with you. You're going to have this inspected, and you want to do everything that you can to do a great job with it. Before you even start wiring your panel, I would highly recommend contacting whoever the inspector is in your area, letting them know what you're going to do, and see if they have any tips. You want to make a plan before you get started pulling wires into the panel for where you're going to put your different circuit breakers. So write out all the circuits that you have on a piece of paper, and you can kind of see the concept that I used here. I put all my double pole breakers on the left hand side there, as well as the surge breaker, which is also using 2 slots. And then I put all of my single circuits on the right hand side. And starting at the bottom right there, you can see I've got my lighting circuits. I literally have 3 breakers for the whole house. They're all 15 amp circuits, so I ran 14 gauge wires to those. The basement and outside lights and smoke detectors. You put the smoke detectors on the same circuit as a light circuit, that way you notice if that gets turned off. And then the main level lights right above that, and then the attic and upstairs lights. And then up from there, you can see I kind of covered the kitchen, and then I covered outside, and then kind of the rest of my general circuits going across, the bathroom circuits, and then at the very top, those top 3 breakers are the only 3 breakers that are actually normal breakers. They're not dual function, ground fault, or arc fault. They're just normal, which is kind of interesting. And then going down there, you can see where I have DF written next to the breakers. Those are ones that I'm potentially going to have be dual function breakers, so they'll be both ground fault and arc fault, and that'll prevent me from having to install ground fault outlets throughout the house. I might do a combination though, and so that's not totally decided on. And then the one spot where I moved the dining room receptacles to be on the 3rd kitchen circuit, that's because the dining room actually has to be on its own circuit, and it can't be shared with other general receptacles. Something that I learned after the fact from the inspector. I'll be using a combination of this wire stripper here. It's designed where you can strip the sheathing off. As you can see, we've got 12-2 and 14-2 as options for what can be stripped using this tool here, where you can cut the sheathing and then pull the sheathing off of the cable. And this is called a cable ripper. The wire slides into it, and then you squeeze this down and pull the wire, and it cuts the sheathing just like this. I didn't cut it just now, but that's how it works. So as you see, I've got all my circuits pulled already. They're all ready to go. when you pull your circuits, you want to leave enough where it's dangling down below the panel about 3 feet. You just want to make sure you have plenty of wire. You're going to end up snipping a lot of it off, but it's going to be able to be put to use elsewhere in the house as pigtails and other things, and it's much better to have a little bit extra that you have to clip off than to not have enough. Now I went ahead and knocked a bunch of these knockouts open up here. I'm going to bring all my wires in the top of this panel. It can be brought in the side depending on how you want to wire yours, but that's the way we are going to do it here today. So I'm going to start by bringing all my wires into the panel and stripping the sheathing off. I'm going to bring the sheathing into the panel by about 3/4 of an inch or so, and then take the sheathing off of each cable, making sure to keep my labeling on each of the black wires as I bring those in, and the white, really. I'll probably put them together. And then I'm going to start by bringing all of my grounds down to my ground bar and lay those all in there really neatly before I go on to anything else. So that's going to take me a little while. I'm going to let these time lapses play through in their full length, that way you can see all of the details. So we're going to start with our dryer wires here. These are 10 gauge, 10-3 wires, so they have 3 insulated conductors and 1 ground. We're pulling those through a single 1/2 inch knockout. And make sure that you have your knockout or your cable clamp or connector in place before you pull the wires through it. And I trimmed those wires back before pulling them through because they're back behind those service entrance cables, as you can see. So it was be difficult to pull the wires through and cut the sheathing off if I had left the sheathing on it. Then we're going to take the markings that were on the end of that wire there and slide them over the wires after I pulled the insulation off. And then we're landing those ground wires there in the bottom of the panel. Now we're opening the knockout here for the range wire, the electric range, and putting in that 3/4 inch connector. So this is a little bit larger connector, and this is a 6-3 wire. So we have 3 insulated conductors again, and this is a 6 gauge wire. So I'll link in the description to the different size wires that I used for these. And again, bringing that ground wire down to the bottom. And we're putting the ground wires down in the bottom of the panel there because that is where they are most out of the way. So we mounted that extra ground bar down there. You can see that I have a ground bar on the left, and that could work, but it does take up more gutter space. So to bring the wires down over on the left and make all those bends right there would take up quite a bit of gutter space. So by bringing them all the way down to the bottom, that space isn't used for anything else usually anyway. So we can put all those ground wires there. You can do this with the ground wires because they don't need to be separated for any specific reason. They're all tied together, and so they can all go in right away, and you don't have to worry about keeping track of which ground wire is from which circuit. Unlike with these 12 gauge wires or all of the rest of the circuits, we need to really keep track of both the hot and the neutral. It used to be that you only had to keep track of the hot wire because it was going to a traditional breaker. But now that we're using ground fault or arc fault breakers for almost everything in the house, you need to keep track of both the neutral and the hot wire. So make sure you take that marked piece of sheathing from the end of the cable and slide it back up over the neutral and the hot wire to keep track of it and keep all those circuits separate. And then we're just hanging those wires off to the side there so that they're not hanging in our face too much. And we did those big wires all first just to get those really stiff wires out of the way and done so that we can work with these smaller circuits. And we're pulling through the 12-2 and the 14-2 wires. We can put 2 cables or 2 14-2 wires or two two 12-2 wires through one single 1/2-inch knockout and cable connector, which is nice because otherwise you'll run out of knockouts pretty quickly if you only run one cable through each one. And then I ended up actually using a utility knife for trimming back the sheathing on these, on a lot of them anyway. The cable ripper tends to be a little bit, it can sometimes damage the sheathing or the insulation of the conductors, as well as a utility knife could, but just make sure you're really careful, and you can run the utility knife down the center of the cable where there is that bare ground wire anyway, and you won't damage anything. So we're pulling a couple more through here. And when you tighten up those cable connectors, you just want to tighten them up until they're snug enough to hold the cable in place without it moving. But you don't want to tighten them so much that you damage the wires by crimping them together super hard. And then we are anchoring the wires with these multi-cable staples, which are super handy because you can open them and close them again. They kind of snap open and snap closed. So I'll link those down below. And we need to anchor the cables within 12 inches of the panel. Wherever they come out of the knockout, they need to be anchored within that 12 inches. And as you pull the cables into the top of the panel, make sure you just use the back knockouts first. Just makes it a lot easier, and then you can kind of just work back to front that way. And we've got the 12-2 cables again that can go through in pairs, as well as the 14-2 cables. Anything that is a 3-conductor cable, like a 14-3 or a 12-3, should probably have its own knockout, as well as the larger wires. Alright, so I've got all of this half pulled into the panel and the ground wires brought to the ground bar. And it's kind of a pain, but thankfully I'm done with my big ones. I got my range wire and my 2 dryer wires in here now. So all I have left is these, so no big deal. Yeah, I'll show you a close-up of what the ground wires are looking like. Alright, so I'm keeping my wires really nicely tucked right in that corner there. And you can see that I bring them down to this level and then make them have a turn directly that way and then down. So as I pull all these wires in over here, I'll be doing the same thing, bringing the wires straight across and down. There's the first ground bar that I'm really not using because I have that other one in the bottom. So here's our ground bar. When you're landing your ground wires, you can put multiple wires under one screw. Now, if you have enough space, I would suggest just going with 2 wires per screw. In fact, I believe this bar right here, according to what I'm reading here on the tag that goes with it, it says 2 14 or 12 gauge wires that are copper. So that's what is recommended for this bar. Now I could be reading that incorrectly, but overall I would stick with 2 per screw, especially if you have space. You can see I still even have extra space here. And if you really want to, you can just do 1. Alright, so now what I'm doing is I'm installing the breakers. I know that I may have to pop one out at a time to attach wires potentially, but I'm doing this whole pigtail situation thing, unrolling each one and then pulling them or hooking them into the neutral bus. Always start with this back row first when you're putting your neutrals in, because you'll be glad you did, because if you fill up the front row first, you will be wishing that you would have filled up the back row first, because it's a lot more difficult to get to this back row after the fact. And get it good and tight. So up here when you're landing your neutral wires, you just have to remember that you're only allowed to put 1 neutral wire under 1 screw. Unlike grounds where you can be allowed to, I think by code you can even put up to 4, but you need to look at your panel and make sure that the requirements of the panel aren't different because, like that grounding bar said, you can only have 2 grounds under 1 screw. Wow, this looks really nice. You know, I'm pleased with this to date, or to this point. Sometimes people will take and put tags on each one of the wires as they come into the breakers. It's kind of like this tag right here. It has its destination written on it. That's a really good idea. It's a lot better than nothing at all. It actually might be the best method. But in order to keep my cabinet as clean as possible, I'm going to just number them that correspond to each location. So 2, 4, 6, 8, 10, and so on. And put that on the black wire for each circuit. And then what I'll have is a legend, or maybe that's the wrong word, but basically on my cover for my panel, I'll have the exact description of what those numbers go to, which is currently what's on like these tags here. But just to not have all of these little bits of sheathing in here, I'm just going to use numbers and put them on here. Because the main point of having a number on here and then having a way to figure out what that number means is that if you take some of the wires off of the breakers and then you forget which one was which, then you have a number that tells you where it went, and then I'll have a paper that tells me what each one of those numbers was supposed to go to. So that's what I'm going to work on now, and I'm just going to work on figuring out the best way to route these cables in here that looks really neat and is very functional. So I think I'm going to bring all of these down on the right here, and you can do it a couple different ways. You can either clip the wires at the exact length that you think you need them to be, which is what I've seen some electricians do, or you can take it down a little bit further and then come back up to the breaker that you want to go to, which is the method that I'm going to take because I really like the flexibility of having a little bit of cable left over in the cabinet, so that if you want to move it later you can. So that's again a preferential thing that I like to do, because if I put my wire that comes to this breaker, if I just bring it straight down and then land it, it's not going to be able to move anywhere except for right there. So if I bring my wires down and loop them back up and in, it's a little inconvenient to get all the wires bundled in here, but it should be pretty well. It should work pretty well as long as I keep it organized. So you can see that I pretty much have all of my breakers installed. You can see on the right hand side there that bundle of white wires coming up. That's all of those pigtails coming from those ground fault or dual function and arc fault breakers. And that's the nice thing about plug-on neutral, is it prevents having all that wire there. It just simplifies things a lot and saves a lot of gutter space. So we're bringing our wires down now and then back up again so that we can have a little bit of extra wire that's saved in case we need to move them around in the future. And then you want to take the wires that are coming in the back of the panel, so the very top on the back, and take those wires down first to land those on the breakers. That way it just makes it a lot easier as you go down and land them. So you don't land them in the order of the breakers being installed. You land them based on which wires came in the back of the panel first. And it works out pretty good that way. And then we actually have one normal breaker here. It's amazing. And we're going to land that neutral right there on the top, like you used to do. And then the hot wire goes straight to the breaker. When you're bending your wires around corners, just pay attention to how sharp you're bending them. You don't want to bend them too sharp, otherwise it can kind of create a hot spot in the wire potentially and just weaken the wire in general. So one guideline I've heard is using kind of the radius of the bottom of a pop can, just as kind of a reminder of that's about how sharp of a curve that you really want to have on a wire. Alright, so here's what it's looking like. Got a loop at the bottom, right there, that loops down and then back up again, and then I'm making a turn on them, and I'm making 2 labels for each one. Since the neutrals and the hots have to go together, I'm putting a little label on each one with their respective number for the circuit. Alright, we're down to the last couple here. This is number 26. as I pull the piece of sheathing off that was on the wire, I write down the number on it, and I take my little tags, set them here. When fishing these wires through the cabinet, towards the end here, it's been kind of tricky. It's getting kind of full. So I take my electrical tool here and just twist the ends together a little bit. It makes it easier to push it through where you need to get it to go. Once you kind of get the hang of it, you'll know kind of about how long it needs to be. About like that, and then I clip it right about here. And then I strip this back. Being sure to use the right spot. Slide your tag on. It generally is easier to get the wire underneath it if the screw is loosened. Gotta make sure all the tags are super organized and beautiful, because nobody's ever going to look at them. So these are really heavy duty wires coming into this breaker here, and this breaker is for the range. And so since they are so heavy, they are a multi-stranded wire. And so what happens is when you first insert them into the breaker and tighten it down, you can tighten them really far, but it'll feel like it's tight, but they could work loose. So what you got to do is kind of wiggle that wire back and forth in the connection, and then retighten the screws again, and then you'll know for sure that you've got a really good connection on your breaker there. And straightening out the wires is kind of a time-consuming process, but the product in the end is, I think, worth it. It's pretty fun. So just a couple of things to point out to you guys so you're not too concerned. These two breakers up here, those are just to hold those wires in place temporarily. I didn't have another 30 amp double pole breaker, so that is a very temporary thing. Now on the left top here you can see there's my surge breaker. I'll link to that in the description. It's a pretty cool device. It's a surge protector for your whole house. But I wanted to note that I contacted Square D, and they recommended actually that I tie that neutral coming out of that surge breaker straight into the ground bar, even though technically it says to put it to the neutral bus. And the reason for that is that since this is in a sub panel, the sub panel has its own separate grounding system and stuff. Not separate, but it has the ground separated. And so you want that to go straight to the grounding rods that are for that building, and not to the neutral bus in this case. And you also want that wire to be as short as possible. So I just wanted to note that I'm aware of that, and just in case anyone else decides to put in a surge breaker. Now I had all of the wires draped all the way down to the floor pretty much, and some of them were even like laying on the floor a little bit. And I thought that it was going to be really excessive, but actually it wasn't terribly excessive, so definitely don't skimp on the amount of wire hanging down below the panel. So there you have it, the panel's wired. This took about 10 hours of time, I'm guessing, approximately. And it may take you less time because you're probably faster than me. Doing a detailed job like this takes a little more time, but I think it's worth it. This has been how to wire your main electrical panel. I hope this helped you out in planning and design and implementation of a main panel in your house. And if you have any comments or suggestions, please leave them down below. Anything that you think would add to this video, or information that I may have missed, please just feel free to comment. That would be terrific. Thanks for watching, and we will talk to you in the next video.